Very good afternoon, Ronana. I am Maripriya here. Sir, good evening, sir. Sir, can you hear me?
Yes.
Okay. I am thrilled to introduce Mr. Mohammed Ameer, sir, a renowned training professional and an AI educator. With expertise in generative AI, deep learning, and IoT, he has conducted over 150 workshops and trained 6,000 plus professionals. Certified by Google, Intel, Microsoft, and more. He has worked with top corporates like DXC Technologies and Deloitte. Sir has collaborated with prestigious institutions like Stanford University and IIT Palakkad. He simplifies complex technologies, empowering professional science students with future-ready skills. His passion for innovation and commitment to education make him an exceptional thought leader in India's tech ecosystem. Good evening, sir, and welcome to you, sir.
Yeah. Thank you. We can start. We'll start with the webinar.
Yes, sir. We can start, sir.
Okay. Fine. Thank you. So let me quickly share my screen and we will begin the discussion. Okay. So I hope my screen is visible. Hello, everyone. As you have already heard, my name is Mohammed Ameer, and I'll be the trainer for this particular quick session on generative AI. So we are going to discuss a couple of things with respect to what exactly is Gen AI and how do we actually consider working with respect to this. So I'm going to split my session into two different parts. One is a quick overview on what exactly is generative AI and how you can use working with different LLM models, especially the open source LLM models. And after that, I'm going to go for the second section, wherein we are going to understand one of the most important aspect of Gen AI. So we are going to work with a RAG-based model. We are going to understand what exactly is RAG and how you can implement RAG using open source model. So if you have any questions, you can please put them in the comment section and I'll try to take it up from there and try to answer you. Okay, so let's quickly go to the PPT. Let's try to understand. We'll start from the basics. So when we are talking about generative AI, you need to understand that Gen AI is actually a specific field which is related to the concept of artificial intelligence. So this is what you get to see here. We have got artificial intelligence, which is considered as the outermost bubble. And inside artificial intelligence, we have got a specific field called as machine learning. Inside machine learning, you have got something called as deep learning. And in deep learning, this is where you would be actually getting a specific field related to deep learning called as generative AI. So very quickly, just to summarize what exactly is generative AI, it is a field which is related to the generating part. You're going to work on generating a specific aspect. It can be maybe a specific type of data, but it is a subfield of deep learning, which is again a subfield of machine learning. And then eventually what you're going to get is artificial intelligence here. So I hope the overview is clear. We are going to understand the definition of generative AI in a while, but for now, just understand that it is the one of the important aspect when it comes to the concept of artificial intelligence. And obviously, generative AI is making a lot of rounds here. We are going to understand a couple of terminologies related to it as well. So one of the important aspects with respect to generative AI is the usage of something called as LLMs. So LLM stands for large language models or language large models. Basically, these are a specific type of models which are used for working with different kind of generative AI applications. So when we talk about, let's say, generative AI part, generally what happens is you're going to generate a new content from that particular thing. So you have got a specific kind of data available with you, but then with the help of the LLM, which we also call as foundational model. We are going to create, let's say, text. We are going to create, let's say, a code, or we are going to generate a new image out of it. So just to quickly show you what we have already probably seen. So you must have heard about chat gpt, which is considered to be one of the most amazing tool out there. So basically what chat gpt does is, it is a chatbot, it is an interactive chatbot, right? You ask a specific question and you get the reply for that particular thing. For example, if I ask here, what is the capital of India? I'll just zoom in so that you are able to see it very clearly. So I'm asking a question and I get back a response. Basically, this is what we call as text generation. It is actually able to generate the text with respect to a specific part. Maybe you might be considering that this is not generating text. We can try out to generate a text. I'll write here, write a poem on, let's say, cricket in 2 lines. Okay, so what it is trying to do is, it is trying to meet some kind of analysis, and it is trying to generate a new kind of text with respect to this. And it doesn't limit here, right? You can actually do generate a new image as well. Maybe I can write here, generate an image wherein a cat is, let's say, flying. Okay, and it is going to generate a new image. So you're able to see here, a new image has actually started to process, and you would be able to see, obviously it might take some time to process because this is a free tool available. It will take some time to probably generate the image, but eventually it is going to generate and give you the output. So the idea what I'm talking about here is, when we are talking about generative AI, it helps you generate the text. It helps you, let's say, generate code or even maybe image. It can help you to generate a lot of different things, right? That's the whole idea of generative AI. When we talk about generative AI, there are different types of Gen AI models available out there in the industry. So I have listed here a couple of them, but then the most prominent used model is what we call as transformer based model. So this is something which I have highlighted here. Transformer based model is the architecture which is actually taking forward a lot of examples. So we have got a lot of different types of models as well, but then I would suggest you all to be quiet if you don't have any questions. Otherwise, it is just going to disturb everyone. Thank you so much. So if you have questions, put them in the comment section. Thank you for understanding. So as we were talking about the types of generative AI model, the most prominent type is transformer based model. Basically, this transformer based architecture is the most popularly used one, because somewhere around, let's say, if I go back to maybe a slide wherein we talk about language modeling history, so you would understand that in the field of, I'm just talking right now with respect to text based things. So we are not talking about images or video or code or anything as such. I'm just focusing on text, which we can also consider as natural language processing part. So basically, this is the timeline that we have, let's say from 2000 to 2022. Okay, this is the timeline that we have. So whatever is indicated, let's say in the gray shade, right? This is something which happened, let's say, before the deep learning era was there, right? So here we had a couple of natural language models, but then they were not so great to understand the task that we have. They were not able to generate new content, right? There were a couple of different disadvantages which were existing before. But then after 20 let's say 19 or 2020 sorry 2010 or 2012, this is where it gave rise to a lot of new variants. So for example, we have got here a couple of different aspects. We have got word to vec, we have got RNN, LSTM. Now these are all the technical terms, obviously, but you can consider this particular thing to be referring to, let's say, new architectures which were available out there, and slowly they were trying to solve a specific issue. So if I have to tell you in simple terms, let's say you want to work on maybe a very simple application in the field of natural language processing, and the most popularly used application is a chatbot. In fact, chat gpt is also a well-known application of a chatbot itself, right? So let's say you want to create a chatbot application predominantly in the field of natural language processing. This particular application ranks on the top because it is one of the most popularly used application out there, right? So if you want to create a chatbot, you would want first of all chatbot to understand what you are asking, right? What input you are giving, it should be understood first of all. So that is something what we call as natural language understanding. It has to understand the nuances of a language first, and then after that it has to generate a new response. So you identify two important problems with this. First one is understanding, and the second one is after it has understood, it has to generate something, right? It has to give you the output. So till this particular time, till the time where we had this transformer, where we didn't have transformer, it was not able to understand the text, nor was it able to generate the text properly. Due to the advent of transformers somewhere around 2017, so transformers were actually created by Google. So it was invented by Google, and it became a landmark in the field of natural language processing. And then it has been buzzing out from then on, right? So you could see the exponential rise in the field of generative AI. It could do a lot of different things, right? So this transformer architecture is something which is considered as a landmark in the field of natural language processing. And after that, there were a lot of different architectures related to transformer base. We had BERT, we had GPT. In fact, in chat GPT, the T stands for transformers, right? So you can understand how important that particular paper was with respect to the way it has been turned out to be. So when we talk about a lot of different LLMs out there, or I would say a lot of models which are available out there, LLM stands for large language models. Basically, these are the machine learning models which are mostly developed using transformer architecture. So if you can see here, we have got the base year transformer, which was released in 2017. Then we had a couple of them from Google. As you can see, Google has its own transformer based architecture, or one of the most commonly used model, which we call as BERT. Then it gave rise to a lot of different scenario, a lot of different transformer architectures. We have got GPT-4 from OpenAI, which is the base right now of ChatGPT. Then also Google came up with its own chatbot model, wherein we tend to use Gemini Ultra. So this is the chatbot model that we have. Also, apart from that, Meta launched its own models. So these are all the most commonly used models out there. So if you talk about generative AI space, these models are predominantly in the I would say highest zone possible. So if you are dealing with Gen AI, then I guess these are the models which you need to work out with, right? So this is where we are right now. And I guess apart from this, there are a lot of models also available out there. This is a little older, I would say, picture. In the field of Gen AI, a lot of models come every day, right? Every day there's a new model out there. But then again, all of this are large language models, which helps you to generate specific kind of things, right? Mostly it deals with text, but then there are some models which deals with multimodal aspects as well. That means along with text, it also deals with images, it also deals with audios, videos, code generation, a lot of different things. Okay, so we have understood what exactly is Gen AI, what it is trying to do, what problem it is trying to solve. So I also spoke about a couple of models, but then I never really differentiated between these two. So this is a good time for us to now understand what are the different types of LLMs available out there. So when we talk about LLMs, I am especially focusing on generative AI models because there are so many different types of LLMs out there. So for example, we have got something called as encoder and decoder architecture based LLM. We have got decoder only LLM. We also have got encoder only LLM, right? So basically, these are the three different types of models which are available out there. But then in this, the most commonly used model for generative AI is decoder only. Okay, so for example, if you see here, GPT-3 is decoder only part, right? GPT-2 is also decoder only part. So Gemini is also decoder only part, which means it works with only the generating aspect, right? There are other models which works with a lot of different NLP tasks available out there. For example, we have text summarization, we have got named entity recognition, right? There are so many different things available out there, but then we are going to primarily focus on decoder only part. So in decoder only part, when we talk about types of LLMs, we have got two different types. One is what we call as closed source, and the second one is what we call as open source. So what is the meaning of closed source? As you might have known, in the software industry, any software which comes out, it can be either a part of closed source environment, which is mostly going to be commercial and it is going to be paid, right? Or else we can have open source platforms or open source tools available out there, which means you actually know the schematics of this particular models or of the software that you're going to use. So open source models are those models which wherein you know what is the model which is actually trained upon. It is not a black box. You already know what are the model weights which are available, what is the model architecture, what is the summary of that particular model. Everything about that particular model will be available out there, right? So the main difference between closed source and open source, if I have to tell you in simple terms, uh, with respect to accessibility, open source models are freely available. Okay, they can be downloaded, in your local system. You can probably utilize it very easily. The problem with closed source is that it is restricted. You'll not get the entire model. Mostly the model is actually called via API, or obviously you'd have certain paid services with it, which means that you don't really have to download your model inside your system. You'll have to just call an API, hit an API, and you will get the request for utilizing that particular LLM model. So OpenAI's ChatGPT or OpenAI's model, which is what we call as GPT-4, it actually is working on the closed source domain path. Okay, which means it can't be used for free. So ChatGPT is a open application out there, but then if you want to create your own LLM powered application, you want to create your own chatbot with the help of OpenAI tool, then you will have to pay for it. It is not available for free, right? Apart from that, customization, you can customize the open source model very easily. Fine tuning is an option here. It can be modified for specific task. Again, this particular thing can also be done, but then it again focuses on API capabilities. Okay, it is restricting you with respect to API capabilities. When you talk about cost, this is free to use. Only for deployment, only for putting it out there, you will have to probably use the infrastructure. Otherwise it is free to go. But then closed source LLMs comes with a price, right? You'll have to pay for whatever you're trying to do with respect to this. When you talk about performance, generally closed source models are highly optimized because they are trained on massive data sets, and these models are huge, right? Some models are even greater than 100 GB or even more, right? But then open source models, they are good, they can do decent tasks, but then it would require a lot amount of optimization and fine tuning. Obviously it comes with both of these models comes with pros and cons, but then as a beginner, you can go ahead with respect to open source, and you can work with respect to this. You can also go for closed source, but then most of the closed source are paid ones, right? So it really depends what you want to do and how you want to go ahead with respect to this. I've listed here a couple of examples. The most commonly used open source models, Llama, it is from Meta. We have got Mistral, we have got Falcon, we have got Grok from Twitter, we have got Bloom, right? These are all the open source models. The list is endless. There are so many models available out there. If you talk about closed source model, we have got GPT-4, we have got Gemini, we have got Claude from Anthropic, and all of the other things available out there. One major difference with respect to open source and closed source model is that when you're downloading open source model, it is going to be very big, right? The storage size actually comes into picture. So for example, you will not be able to download, let's say, models which are greater than 20 GB, because most of the laptops will not have 20 GB RAM unless you have high requirement, or unless you have that particular high configuration computer, you will not be able to use open source model. Although there are open source models which are small, which are distilled version, but then to get that let's say efficiency and to get really good output, right, you might have to use really bigger models for the same. Okay, so that is one drawback which we have with respect to open source. Okay, so we have understood the base about all of this. I will quickly talk about the next section, wherein I can probably show you a quick demonstration about this particular thing. So these models that we have, does it work better, or I would rather say, does it work fine always? Is there that there is no problem with LLMs? Obviously, any tool, when we are actually using it, there might be certain bugs, or there might be something which might not work as required, right? So I have got here three important topics to discuss with respect to where the chat models, or where the normal LLMs that we have actually fail. So the very first one is what we call as hallucination. Basically, now ChatGPT has got access to internet, which means that real-time events can actually be considered, and it will eventually answer you all of the details that we have. But back in the day, when ChatGPT was really new out there, right? If you'd have asked any question related to, let's say, latest topic, there would have been two responses. One response would have been that it would say, maybe, something like this would have happened. Let's say you ask what is the let's say weather in Bangalore today, right? And it would directly answer saying that the Bangalore weather is, maybe, it is cloudy or raining or whatever it is. It is answering in a false manner because it is not trained on that particular data. Although it is not trained on the data, it hallucinates, or it answers wrongly. That answering confidently the wrong answers is what we call as hallucination. Okay, so most of the chat models try to answer without giving the facts. They give you wrong answers with respect to a specific domain or any question that you ask, right? So that is where one of the place where maybe chat models actually fail. Second place where maybe chat model, or even the chat GPT which we can try fails, is with respect to, okay, I think so I've already spoken about recent information. Nowadays ChatGPT actually has got access to let's say the news, or maybe the Google or internet. That is why it is able to answer whatever are the things, but then previously it was not able to answer that particular thing. If you are working on, let's say, a specific LLM, open source LLM, it will have a training cutoff date, right? That means beyond that it will not be able to answer a specific question. Same thing can be applied for another place of application, which we call as company private data. Let's say that I have got a company wherein maybe I sell, let's say, automobiles. I've got cars, automobiles company. So I want to integrate, let's say, car manual kind of a thing, like a chatbot inside my automobiles or inside my cars. What am I supposed to do? I can't utilize ChatGPT for doing this, right? Because this is my internal company's data, and obviously I can't utilize it with respect to, let's say, ChatGPT or any other application. I'll have to create something on my own, right? So that is where we can't rely on the models which are available out there. That is why we might have to go for different techniques to actually kind of consider that your model doesn't hallucinate, your model has got information, recent ones, and your model can also get trained or can also answer questions related to your company's private data. Okay, so this is where RAG actually comes into picture. RAG stands for Retrieval Augmented Generation. Basically, what happens in RAG is that you ask a question and then there will be a retrieval system wherein it'll actually look for some relevant documents, and the documents can be anything. You can have, let's say, a lot of PDFs, a lot of text file, or maybe something available on the cloud, anything as such, right? And then you can actually extract that particular information with respect to a generated output. Okay, I'll try to show you a very simple example with respect to this, and let's go to this particular thing to see whether we are getting the output. Okay, so as you can see, I had created an image. It took some time, but then you're able to see flying cat image, right? You're able to see both of the responses. So it is able to generate realistic images with respect to this particular thing. This is what I was talking about. All right, so what I'll ask is, let's say that there's a company by the name of Fizz Junction. Okay, so I'll just ask a question here. Tell me, sorry, wait. So let me ask here, what is Fizz Junction? Okay, I'm asking a simple question to ChatGPT, what is Fizz Junction? So it is going to respond me by saying, let's just see. I think so a little, I have used it. Maybe it is slow. What I can do is I can create a new one. I'll ask here, what is Fizz Junction? Okay, so as you can see here, it just says that Fizz Junction does not have a widely recognized definition across mainstream fields. That means this is something which is not recognized or which is not trained upon. At least it is not hallucinating. It is just trying to tell me that I don't know what exactly you're talking about, right? But still, it is not answering my question. Let's say that I run a company called as Fizz Junction. Maybe it provides refreshing drinks, right? So it is not able to answer me that particular question. In that case, what I'm going to do is I'm going to use an LLM. I can use GPT-4 also, but then it is going to be paid, so I can't utilize that particular thing. I'll use an LLM which actually will take the task and it will actually give me the output with respect to this particular thing. So where do we find open source LLMs? There's a directory or a website called as Hugging Face. So Hugging Face is a platform wherein we have got multiple models available out there, and you can do a specific task related to all of these particular models. For example, in the field of computer vision, you can do object detection, you can do image classification, or let's say in the field of natural language processing, we are dealing with text generation, right? So you can actually play around with text generation and you can do a lot of applications with respect to this particular thing. So I'm going to take one model which is open source from Google, and I am going to actually show you how that particular thing can work out. So let's quickly go to this particular model which is available out there. Okay, so I'll just, this is my Google Colab window which I'm going to use, and we will be able to see the output with respect to this. So I'm trying to work on a RAG based application. We'll come back to how RAG works a little while later. But for now, what I'm trying to do is I'm trying to install a couple of libraries. And this is happening purely in Python programming. So I'm installing a library called as LangChain, LangChain Community, LangChain Hugging Face, and a couple of other things required for working with respect to this. For now, I'm going to dedicatedly work on Transformers library. So Transformers is a library from Hugging Face, which allows you to work with all of their open source models. So I'm taking a model by the name of Google Flan T5 Small. Okay, I'm taking a very small model. I can maybe show you in Hugging Face as well. So let's go back to Hugging Face. And I'll search here for a model called as Google Flan T5 Small. So Flan T5 Small is a model which is open sourced by Google. Google has got both closed source as well as open source. Closed source is Gemini. Open source is, there are multiple open source models. We have got Flan, we have got Gemma, the recently released one. So what this particular model actually does is, you can work on this particular model for text to text generation and get the output. So if you can see here, inference provider indicates that it is used mainly for text to text generation. That is what we are trying to do in generative AI. I just want to go to files and show you how small this particular model is. So it is roughly around 308 MB. That means it is less than half a GB, right? So it is good, at least for our exploration or for the demonstration that I'm trying to show, as compared to, let's say, Llama 4 model. So basically Llama 4 or let's say Llama 3 model. Okay, I'll show you with respect to Llama 4 itself. Llama 4 is a model recently released by Meta. Llama 4 Scout is the model which I'm taking. And as you can see here, it's a huge model, right? Can you see this? There are so many models available, model tensors which are actually available. Every model tensor is of 4 GB. And I think so there is roughly 50. So you can consider 4 multiplied by 50. So it is somewhere around 200 GB. It is humongous, right? As compared to let's say Flan model, this particular thing is too big. I'm taking something which is very small, which can work very well on my let's say Google Colab as well. Those Llama model, Llama 4, I will not be able to load at all in my Colab file, because I know that in my Colab the maximum RAM which is supported is 12.7 GB. So this particular file, this particular model is actually available very easily, so that should not be a problem. I have loaded my Google Flan T5 small model. I'll ask here a simple question again. What is fizz junction? Okay, we had asked this question to ChatGPT. Let's see what answer does it give here. So it is trying to take into action, and can you see here, it is hallucinating. It is giving me some wrong answer very confidently. It is saying that Fizz Junction is a railway station in the city of Fizz. It is trying to come up with some random answers, right? Because it has not been trained upon this particular part. So what we will do is, we will actually give it the base. We will give the document. We'll tell how you can go through this particular thing and probably generate something from it, right? So let's try to understand a quick overview of RAG pipeline. So RAG has got two important components. One is what we call as indexing, and the second one is what we call as retrieval and generation. Indexing basically means that you're going to source a file and you're going to put that particular bigger file. If you have a bigger file, put it into smaller pieces and then convert them into the let's say a way wherein model understands that particular thing. Okay, so we will see what happens in indexing. And then after that, the second step is we have got the retrieval. So from that indexing source file, we retrieve the required document and then we generate a new text. Okay, these are the two important components which are available. So if you talk about indexing, there are 4 subcomponents, which is fairly simple for us to understand. First component is to load. For example, make sure that you have a file available. You have, let's say, a PDF file, or maybe a JSON file, a CSV file, anything, a specific file will it should be available, which LLM has to go through. That particular thing should be loaded. Okay, the second one is, if your file is too big, you'll have to split it into smaller chunks. So splitting helps us to make sure that you don't have to go through each and everything, right? Let's say there are 10 PDFs. You are asking a question related to a specific PDF. You don't have to search entire 10 PDF. You'll have to take only a specific PDF and get that particular answer. The third step is what we call as embedding. Basically, embedding, you can consider it to be a way wherein you convert your text related values into numbers. So these are not normal numbers. They are in the form of vectors, which actually gives you semantic meaning. That means every text value is actually closely related to a specific value. So let's say that if there is a sentence wherein it indicates maybe kitten and let's say cat, this cat and kitten words, they are related to each other, right? Their semantic meaning is somewhat similar to, let's say, dog and maybe a puppy, right? They are related to each other. Man and woman, they are related to each other. So the semantic search meaning will actually be closer with respect to that. So embedding does that particular part. It converts into numbers wherein you get a specific kind of meaning, and finally you store it in a database. We refer to this database as vector database. These are the 4 steps which you generally do in indexing. Once the indexing is done, you can ask a question, you can give it a prompt. It will use the LLM power to retrieve the question asked and give you the answer. So let's try to practically see this particular thing. So as I had mentioned that we are going to work with indexing, retrieval, and then generation. In indexing, the very first step is we are going to focus on, let's say, loading the data. So I've given here a smaller data. What I've mentioned here is, let's say Fizz Junction is a beverage company which offers refreshing soda. Their main branch is in Bangalore, India. These are the available flavors. A couple of flavors, they come in different sizes. They undertake bulk orders and for special events, and you can finally contact them via this particular ID. So I've given a specific information with respect to that particular company. What I've done first is I have loaded my data with the help of text loader. If you have PDF, you will have to use PDF loader. So LangChain framework takes care of that particular thing. Then we split our text into multiple documents. So for example, I'm going to split my document into multiple chunks. So I've given here the maximum chunk size. What you can consider is 300 with respect to this particular thing. Once I've got split my data, I will utilize the embeddings. Basically, the embeddings are the models which are already available on the Hugging Face. For example, this particular model is already available on the Hugging Face. I will use this model to actually convert the text which I have loaded. Okay, and this is what I do with respect to a database called as FAISS. So FAISS is a library, or we can say it is a vector database from Facebook, which helps you to do semantic search very easily. It is a vector database which holds a lot of information related to that particular text. Once that is done, we generate a pipeline wherein we ask a specific question from the retrieval method, and then we get the answer. For example, I'm asking the question again here, what is Fizz Junction? And then you will be able to see it gives you the answer saying that Fizz Junction is a beverage company. At least it is not hallucinating right now. It is working with your private data and it is giving you really good answers as well. I can ask another question. Let's say how to contact Fizz Junction. Let's run this and you should be able to see that you can contact Fizz Junction via this particular email address. So the idea here is very clear. It is trying to answer you based upon a specific content, right? Based upon your private data, it is actually trying to answer this particular thing. I think so this has to be result, and there you go. So the idea is very simple. With the help of RAG, you will be able to prevent hallucination. You will be able to get new data onboarded on this, and also you will be able to kind of work on private data. See, on ChatGPT, you will not be able to upload your private company documents, right? And also you can't upload very big documents. There is this concept called as context length. That means you can upload only limited value or only limited files for that. And the biggest aspect here is security. You can't upload PDF documents on ChatGPT and ask questions, right? So what do you do? The alternative is you can load this particular model right inside your laptop and you can run all of this particular thing, right? So it's not necessary that you have to do only with text. You can do it with a lot of other variants as well. So I can show you maybe a model which is in fact deployed on the cloud. So I have created this particular model which is deployed on Streamlit cloud. So Streamlit is actually a library which is super helpful for deploying data-based application. So I've created here a chatbot which is based upon a specific research paper. So if you remember, I had mentioned about a research paper called as Attention is All You Need. So it is running on this particular paper. It is the transformer model paper that we have. So I have uploaded here, and maybe you can ask specific question. So let's say here I'll ask a question, summarize the paper. Or I don't even have to mention summarize the paper. When I mention, you will be able to see it loads that particular thing. And can you see here, it is actually summarizing quickly what exactly this particular paper is all about, a technical paper, right? Maybe I'll ask another question, who is the author of the paper? And then you will be able to see here, it gives you the answer. The author of this paper is Isaac Gerber. So if you go back and see here, Isaac Gerber is the author of this particular paper, right? I'll ask another question. What is the heading of this paper? So you can now, I guess, understand what I'm talking about. The possibilities are endless. I've just created a simple chatbot. Okay, what is the title? And you can see here, this is the title. Attention is not all you need. The importance of feed forward network in transformer model. This is what you are actually getting. Okay, that's the base. And I would stop here. If there are any questions, maybe one or two, I can take them and we can stop the session here. Do you have any questions? All right. Okay. So we can stop here. Yes, I'm going to share the PPT and the code with the team so that they can share it with you. Okay. All right, Kavya, I guess we can stop here.
Yeah, hi Mohammed, Mohsin this side.
Yes, I.
I have a question. So I have tried one of the project like creating a medical chatbot or something like that. And can you please advise any kind of models that are freely available to build our own project or something like that?
So you can go to Hugging Face and you can try specific models which are actually available, because if you see here on Hugging Face, right, there are tons of models. I'm not sure with respect to medical field which are the ones, but then you should be able to see multiple models here available in this particular aspect,
Yeah,
right? So
I have used Mistral as a model because
okay,
that was free at the
okay, yeah, you
actually.
can use Mistral. I
So
think so. It's good.
yeah, but it didn't give me the appropriate responses actually.
Yes, that is where I think so RAG is actually going to play a very important role. See, all of these particular models, right, they are generally trained. They're not trained on a specific domain. Okay, so what you can do is you can
Mm,
actually give a RAG based document. You can give maybe a lot of PDFs or a lot of files related to medical aspects, so that it can understand the context and it will be able to answer you based on that particular thing. So
all
probably
right.
what I've shown you is going to be very helpful. You can take PDFs wherein you have got a lot of things related to medical, and then maybe deploy that particular thing so that it will take from that
Okay.
particular context and answer you.
Mm-hmm. Okay, that might be a good approach.
Yeah. So there are
So
multiple
currently
approaches
I had
with
used
respect to this.
one or two books related to medical that are considered as encyclopedia itself. Those
Okay.
books.
Okay.
So but it didn't give me the answer as expected.
Did you try to work on RAG?
No, I actually didn't work on track. I just deployed Mistral and tried to test it.
Okay, so see, there are multiple options. Maybe first thing what you can try is RAG, or else if you are not getting correct
Mm,
output with respect to RAG, there is a concept of fine tuning. So what you do is you fine tune your model with respect to specific document itself. You retrain your model. So fine tuning is actually a costly thing. It is an expensive thing. RAG, it doesn't require training because all of the context is available inside that particular document. You can probably try
mm,
fine tuning. There are so many approaches which are available. There's a library called as Unsloth, which actually helps you to fine train your model very quickly. If you have used Mistral, you can use Mistral with respect to Unsloth as well, and it will do the job very quickly for you. So probably on Google Colab
yeah,
itself, you will be able to do and play around with it.
Yeah, I will try to.
Okay, Anmol
Mhm.
is asking how is RAG used in generating like text. So that's what I told you, right? So what it does is generating means that RAG has got two important parts. One is retrieved, augmented. That means whatever document you have given, it will actually take it into consideration and then it will generate something from that particular context. So that is where generation actually comes into picture, right? It is trying to generate based upon what data you have tried to provide it. It doesn't go through the model of training. You don't have to deal with training here. That is why it is super fast, right? Unlike fine tuning, wherein you will have to fine tune your entire deep learning model, you are just giving here the context and you are making it work. So I can say RAG is something like enhanced version of in context understanding. Okay, that is the whole idea. Image, you can give images also with respect to RAG. Again, it has to learn from that particular thing. So I didn't discuss anything with respect to image today or multimodality part. For images, I guess you'll have to understand fundamentals of vision transformers, how vision transformers are actually worked upon. And then based on that, maybe, you know, RAG can actually be considered. Today, what I've focused is completely on text. Okay, I will stop here. And thank you everyone for attending. I hope the session was beneficial.
Yeah,
Anupriya?
Yes, sir.
thanks,
Yes.
Mohammed.
Yes. We can just thank Mohammed sir with a thank you note, Anupriya.
Yeah, thank you.
Okay, thank you, sir. Thank you so much, sir, for sharing your time, knowledge, and expertise with us. Your session was incredibly insightful and inspiring, especially your deep dive into generative AI, deep learning, and emerging technologies. Your ability to simplify complex concepts and connect with us, with the audience, truly stood out. We deeply appreciate your dedication to empowering professionals and students with the future ready skills. Your experience, enthusiasm, and passion for innovation left a lasting impact, and we are grateful for the opportunity to learn from you. We look forward to staying connected and hopefully collaborating again in the future. Thank you, sir. Thank you very much.
Thank you everyone.
Thank you, sir. Thank you for attending. And I thank everyone attending this event. Thank you all.
Thank you.